Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through basic trigonometry. We're just looking at SOHCAHTOA in right-angled triangles, just like you learned in Year 9. So let's look at this right-angled triangle here. In order to perform calculations correctly, we need to make sure we label our sides properly. So firstly, we need another angle to refer to besides the right angle. I'll call this angle theta. Now the side opposite the right angle, this side here, is always the longest side of the right angled triangle, and we call that the hypotenuse. So now let's label the shorter two sides. The shorter side that is touching this angle theta is the one we say adjacent to theta, and the other one is opposite theta. So the hypotenuse is always the longer side, but the two shorter sides O and A depend on which angle you're talking about. So if I was referring to this angle, then this side would be the opposite to that angle, and this side would be adjacent. But because I'm referring to theta, this is the side adjacent theta and the side opposite theta. So in trigonometry, there are three ratios we're looking at. We're looking at sine, cos, and tan. This acronym here, SOHCAHTOA, tells you when to use which ratio. It stands for sine, opposite hypotenuse, cos, adjacent hypotenuse, tan, opposite adjacent. It tells us we use sine when the question involves the opposite and hypotenuse, we use cos when it involves adjacent and hypotenuse, and then we use tan when it involves opposite and adjacent. So make sure you remember this. This is for right-angled triangles. So we will now look at how we use SOHCAHTOA to calculate the unknown in each of these three questions. So the first step is we need to decide which ratio we are using. So in the first one, we have the adjacent and hypotenuse. So our acronym tells us that we will use cos in the first one. In the second one, so looking at this angle here, we have the opposite and the hypotenuse. So we would use sine, opposite hypotenuse. And then in the last one, we have the opposite and the adjacent. So we would use tan. So after we've decided which ratio to use, we need to set up an equation. So let's look at this first one here. So we know it's cos. It's always cos sine or tan of the angle. So we'll have cos of angle equals, now in this acronym, because A is first, adjacent is first, it goes on top. So it's cos theta equals adjacent over hypotenuse. So we have cos 40 equals adjacent over hypotenuse. For the next one, O comes first when we're using sine, so O goes on top. So this will be sine of angle equals opposite over hypotenuse. Now, in the third one here, this one I coloured red because it's different. We're actually finding an angle here, whereas in the first two, we're finding a side. But we can set up our equation the same way. Tan of the angle that I want to find equals, and because it's O then A, it's tan theta equals opposite over adjacent. So now we just have to solve these equations. So let's look at these two first, which are involving finding a side. So the way that you solve this equation is slightly different. The reason it's slightly different is because here the thing I want to find is on top, here the thing I want to find is on the bottom. If the thing you want to find is on top, you times. So this will be 10 times cos 40. Whereas if the thing you want to find is on the bottom of the fraction, as it is here, you don't times, you divide. So it's actually going to be y equals not 5 times sine 22, 5 divided by sine 22. Now, for the last one, when you're finding an angle, you don't end up using sine, cos, or tan. You use sine inverse, cos inverse, or tan inverse. So usually you just press second function tan will give you this, tan inverse. So that's what I want to come up on my calculator. So theta will actually be the tan inverse of the opposite over adjacent. So I just need to put each of these in my calculator. You need to make sure your calculator's in degrees mode or you won't get the right answer. So putting the first two in my calculator, this one gives me the 2 decimal places 7.66. So it's in meters because the hypotenuse was in meters. And for y, I get about 13.35. I can just write units because the units weren't actually specified here. So just quickly, I don't expect you to be able to know what 10 cos 40 is off the top of your head without a calculator, nor do I expect you to be able to do this. But what we should note is because 10 here is the hypotenuse, x needs to be shorter than 10 meters. So I did get something like that, so I know I've done something right. So similarly here, I'm actually finding the hypotenuse. It's the longer side, so the answer should definitely be more than 5, which it was, so I know I've done something right. Okay, and then we'll do this one in our calculator as well. Again, you probably need the second function, then tan. So this one I'll give to the nearest degree. The answer you get in your calculator is like 36.87, but because it's an angle, it's actually degrees. All right, thanks so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.